Kusuzangpo, welcome to Bhutan e-learning program. I am Balbadur Gurung, teacher at Losling Middle Secondary School. And today I have a lesson for Key Stage 5, particularly for class 11 and 12. And the topic that we are going to discuss is on homologous series and iopic nomenclature. So before that, let's look at the objective of the lesson. So once you go through this lesson, you should be able to actually define what is homologous series. Then you should also be able to tell the characteristics of homologous series, and finally name the organic compound based on the homologous series. Actually, you have been introduced to homologous series and organic chemistry since class 9, and by this time you pretty well know what is organic chemistry. So organic chemistry, it is a branch of chemistry where you study about organic compounds, and we know the importance of organic chemistry. Actually, there is hardly any walk of life where we do not need organic substances. The food that we eat is actually full of organic substances. Then the clothes that you and I wear are all organic substances. The fuel that our car actually uses, the fuel that we use for cooking, the fuel that the industries actually uses are all actually organic substance. We have different types of medicines that comes from organic compounds. Today, you and I have the choice of selecting the favorite colors, because the colors are actually the product of organic substances. We have studied in class 9 and 10, due to unique property of carbon, there are large number of organic substances, and due to this, organic substances have been categorized into different series which we call homologous series. Today I am going to introduce you the basic homologous series of hydrocarbon. Of course, we have many homologous series, but for you I will just introduce you the basic homologous series of hydrocarbon, that is alkane, alkene and alkyne. So this is one homologous series of alkane, and we have another homologous series of alkene, and subsequently we have the homologous series of alkyne. And the important property that the homologous series will exhibit, the subsequent member, the successive member actually differ by CH2 group in all homologous series, be it alkane, be it alkene, alkyne or alcohol, carboxylic acid. If the homologous series will, the members, the nearest member, that is the adjacent member, always differ by CH2 group. And the compounds in a homologous series can be represented with a general formula. So for example, all the members of alkane will have the same general formula. Likewise, we have the general formula for alkene, alkyne, and we also have the general formula for other homologous series like alcohol, carboxylic acid, ketones, and many more. And the members, the compounds in a homologous series, we call it homologs, and the phenomenon, we call it homology. So let's look at the characteristics of homologous series in more detail. So we have the physical properties like boiling point, melting point, density, solubility. So it actually changes gradually as we move down the series, meaning as you go down the series, the physical property will change. The physical property will change gradually. Why does the physical property change? This is because as we go down, the number of carbon and hydrogen atoms increases. Actually, it increases by 1 carbon atom and 2 hydrogen atom as we go down the series. The homologous series will always have same functional group. For example, let's look at methane. What is the functional group there? The functional group is single bond. If you look at ethane, the functional group is again single bond. If you look at propane, again the functional group is single bond. Butane, pentane, hexane, all actually have single bond as their functional group. And since the members of the homologous series actually have the same functional group, they will also have the same or very similar chemical properties. For example, if we talk about the combustion of alkane, whether it is methane that is burning, or it can be ethane, propane, or butane, the reaction will be very similar, giving us carbon dioxide, water vapor, and heat, meaning it exhibits very, very similar chemical properties. And the members of the homologous series can be prepared with very similar general method of preparation. Having gone through the properties of homologous series, by this time you should be able to define what is homologous series. Yes, dear students, what is homologous series? So, homologous series is a group of structurally similar organic compounds with same functional group showing gradual change in physical property. However, the chemical property will remain same, and the successive member in the homologous series will always differ by CH2 group. So this is what we call homologous series. Now, let's look at nomenclature of organic compounds. So you have been introduced to basic of nomenclature of organic compounds in class 9 and 10. So what is nomenclature? Nomenclature means the systems of naming organic compounds. Just we have the systems of naming our children. Some go to llama, some go to pandit, but for organic substances we have the two systems of naming, common or tribal system or IUPAC system of naming the organic compounds. The common system is just like a local name that we usually give. For example, you also have the local name like Cheche. You are called Cheche at home, isn't it? But that common name cannot be used at official level. That common name cannot be used at international level. So you need to have the official name, and for organic compounds, official name can be the IUPAC names. So common name actually is given based on the sources, based on the origin. For example, if you just look at urea, we have the organic compound urea, and urea got its name since it is isolated from urine. And we have very popular painkiller which is morphine. Morphine is actually named after Morpheus, Greek god of dream. And once you are given morphine painkiller, you are as good as in a dream. And the next we have is IUPAC system, International Union of Pure and Applied Chemistry. So the names here, it is not based on the sources, not based on the origin, it is not based on the property, rather the names are given based on the structure. And the IUPAC system of naming consists of three important components: prefix. So here prefix, it gives us where and what are the substituents. Substituents means branch. And word root, how many carbon atoms are there in a parent chain. Then suffix, what is the functional group. So substituents, parent chain, functional group, actually you are already introduced in class 9 and 10. So let me tell you what is word root. Word root basically gives us the number of carbon atoms in a parent chain. If the number of carbon atom in a parent chain is 1, then the word root that you need to use is meth. And if the number of carbon atom is 2, the word root that you should be using is it. And if the number of carbon is 3, your word root will become prop. So it goes bute, pent, hex, hept, oct, non, and dec. So at your level, so till dec is more than enough. And the suffix, actually suffix comes after word root, and suffix are of 2 types. As I was telling you, suffix are of 2 types, primary suffix and secondary suffix. And primary suffix gives us the nature of carbon-carbon bond, and we have 3 types of carbon-carbon bond: single, double, and triple. And if the nature of the carbon-carbon bond is single, then your primary suffix will be ane, because single bond means it belongs to alkane series, alkane, then your suffix will also be ana. If your carbon-carbon bond is double, then it belongs to the family of alkene, so your suffix will also be ene, alkene. And we have the triple bond, then it will be yne, because triple bond actually belongs to the family of alkyne. We have secondary suffix that is added to primary suffix to indicate the nature of functional group. So these are other functional group besides single bond, double bond, and triple bond. Halides, which we also call it as halogen. We have chlorine, fluorine, bromine, iodine. This can be one functional group, halogen. Then OH. As soon as you see OH in organic substances, then you should know that that compound is alcohol. So your secondary suffix will be OL, alcohol. Then CHO, aldehyde. Then you have CO, ketone, ONA. Then you have carboxylic group as functional group. Here you need to use oic acid. Your suffix will be oic acid. If your functional group is COOH, then you need to use oic acid as the secondary suffix. So now let's look at the rules for naming the organic compounds. So basically there are 3 rules that you need to consider. The first one is longest chain rule. So as soon as you see the organic compounds like this, so don't be frightened of the complexity of the compound. So it is very simple if you follow the rules. So the first rule is to identify the longest carbon chain. So you can see there, this is one chain with carbon 5. This can be another chain with carbon atoms, total number of carbon atoms are 6. And this is another carbon chain where there are actually 4 carbon atoms. So which one is the longest chain? Obviously this, isn't it? So there are 6 carbon atoms, and the longest carbon chain is known as parent chain. So sometimes you may be asked to identify the parent chain. So you don't have to be worried. So parent chain means the longest continuous carbon chain. And the next rule that we have is lowest number rule, or we also call it lowest sum rule. So here what we do is, once you identify the longest carbon chain, now you have to number the carbon atoms in a parent chain. And for numbering, you can either number from the left, or you can also number from the right. So if you number from the left, so this is going to be your numbering, and you can also number from the right. So if you number from the right, this is going to be your numbering. And you can either number from left or right, you cannot number from both the directions. So, for that you need to consider certain conditions. Your numbering should be done in a way that the substituents, the carbon bearing the substituent should be given the lowest number. So, if you just look here, so that carbon is bearing the substituent, meaning branch, there is a branch, and the carbon with the branch should be getting the lowest number. If you actually number from the left, the carbon is getting 4. If you number from right, it is getting 3. So, you will have to go with the one that is with the 3. So, your numbering, the below numbering, the red numbering is not correct. However, the numbering that you have done above is the correct numbering. The next rule is, if the branching is on equal distance from the end. For example, so this one is your parent chain. Now you have the branch, 2 branches. Okay, you have one at carbon number 3, then another branch at carbon number 3. From where to start now? Both are at equal distance from the end. So you have another substituent, that is the second substituent. Now you will have to look at the second substituent, and second substituent should also get the lowest number. So if you number from left, the substituent is getting 6. If you number from right, the substituent is getting 4. So basically your correct numbering is the grain numbering. And what if 2 alkyl groups are at equal distance from the end? You have methyl group and ethyl group, and both are at equal distance. Both are at equal distance, that is at carbon number 3. So from where to start? Which one to get the lowest numbering? So for that you have to look at the alphabetical order. The one that comes before or first in alphabetical order should be given the lowest numbering. So methyl means M, ethyl means E, so E comes first. So your numbering should be from the right. And if your carbon compounds, or if the organic compounds actually has functional group, so you should forget about the substituents, you should forget about the branches. The carbon with the functional group will always get the lowest number. For example, you have the functional group, that is OH, hydroxyl or alcohol functional group. So you need not take care of the substituent. Obviously, the carbon with the functional group should be given the lowest number. So our numbering will be from the right. If you number from the left, then functional group is going to get higher number. And again you have another functional group, that is double bond, carbon carbon double bond. So obviously the functional group should be getting the lowest number. Let's look at one more example. So this is the parent chain, the longest continuous chain. Let's say you have selected this. If you number, you have the functional group there, carboxylic acid group. If you number from left, your carboxylic group is at carbon number 2. However, your selection of the chain is wrong here, because you have to include the carboxylic acid in a parent chain, because you see the carbon there. And if you select the parent chain like this, now the carboxylic group, that is the functional group, is getting the lowest number, that is 1. Before it was getting 2, but now it is getting 1. So this should be your numbering. So step 3, while writing down the names, you need to write the names in single words, unlike our names. For example, how do we write our names? For example, Tashi, Tobden, Choden, we write separately, but as per IUPAC, you have to write down together as a single word. Then if there are two numbers, you have to separate the numbers with comma. For example, you have two methyl group. One is at carbon number 2 and another one is at carbon number 4. So you have one at carbon number 2, one at carbon number 4. Now you want to separate this. To separate this, you need to use comma and use hyphen to separate the prefix. So what is prefix? Prefix is a branch. So what is the branch there? You have methyl, CH3. So methyl, to separate the prefix, you need to use the hyphen. And if there are more than one prefixes, let's say two prefixes, then you have to use di. If it is 3, you have to use tri. If it is 4, you have to use tetra. So in our case, we have two prefixes. So you have to use di, dimethyl. If there are two or more prefixes, let's say identical prefixes, then you cannot use di, tri, tetra for alphabeting. For example, you have dimethyl, triethyl. So you cannot use, let's say you have dimethyl, you have another triethyl. Well alphabeting, you should not using the prefixes like this. You cannot use this. You have to alphabet with the name of the alkyl group. So definitely triethyl will come first, then only dimethyl will come. So now let's check our progress. So I have introduced you the rules for naming the organic compounds. So let's name this compound together. Are you ready? So we have the organic compounds. What is the first rule that we have discussed? Identify the longest carbon chain. The first rule that we need to apply for this is to identify the longest carbon chain. So which one is the longest carbon chain? Since there is carboxylic acid as a functional group, so you have to include that in a parent chain. So the longest carbon chain for us is this, or it can be also other way. So let's take this as the longest parent chain. What next now? You need to number the carbon atoms in a parent chain. So let's number. And how to number? The functional group should be getting the lowest number. So definitely you will have to start numbering from right, isn't it? Right direction. So the carboxylic acid group is getting 1 as the number. And I told you that the IUPAC system of naming consists of 3 important components: prefix, word root and suffix. So what is the prefix there? Prefix actually means where and what are the substituents, where and what are the branches. So you have prefix. At carbon number 2 there is one branch, at carbon number 4 there is another branch. So that is what we call prefix. And word root means how many carbon atoms are there in a parent chain. How many carbon atoms are there? So we have 5 carbon atoms in a parent chain. So 5 means it will be pent. If it is 6, it is going to be hex. But for now it is 5, so we have to take the word root as pent. Then what is the primary suffix? Is it single bond? Is it double bond? Is it triple bond? So ours is single bond, means it belongs to the family of alkane. So our primary suffix will be ane, alkane. Then what is the secondary suffix? So we have the functional group there, and the functional group, if it is carboxylic acid, then we have to use the functional group oic acid. Oic acid. And where is that oic acid? It is in carbon number 1. So you just have to combine this. So the name for this compound will be 2,4-dimethyl pen 10, and if the secondary suffix is vowels, not consonant, then you have to remove E from your primary suffix and add your secondary suffix. And the name of this compound is 2,4-dimethyl pentanoic acid, or you can also call it as 2,4-dimethyl 1-pentanoic acid. So from here what we get is there are 2 methyl group, one is at carbon number 2, another one is at carbon number 4. Pent means there are actually 5 carbon atoms in a parent chain, and what is the functional group? Oic acid means carboxylic as the functional group. That is what we get from this name. So with this, so let's see what we have discussed in today's lesson. So we have defined what is homologous series. We have also gone through the characteristics of homologous series, nomenclature of organic substances, basically 2 systems of naming, trivial and apic systems of naming, and you have also looked at the namings of organic compounds, actually the rules particularly. So this is what we have actually discussed in today's class. Now I have the home assignment for you. So what you can do is try defining homologous series. List any 2 characteristics of homologous series. Of course we have discussed many. Then try giving names to these organic compounds. If you are able to solve this, then very purpose of being with me is actually fulfilled. If not, maybe I might not have delivered that well, or you might not have listened to me well. So with this, thank you, and see you in my next lesson.